So part of calculus is looking at rates of change, average rate of change, and instantaneous rate of change. So how far is it to Denver?
3 hours.
It's about 3 hours. Okay, so we want to figure out our average speed or average velocity. It's 180 miles in about 3 hours, right? What's our average velocity? Right? Logan, I'm surprised you don't know that exact decimal.
Yeah, I know I should, right?
It was 180 miles when I drove it every couple weeks 10 years ago. Right to my fiance's doorstep. But I'm a mathematician, so that's how I know. Okay, so it's about 60 miles an hour. Right? This is also can be written. We're at mile marker 75, right? Denver is somewhere around 255. So that's our what we call change in position. These are mile markers off the freeway mile. Time was my initial time. Okay, now what's my position at time 0? 35. Okay, then I have time 1 when I arrive, and my position at time 1 is 255. Okay, so this is calculus notation for slope. We use function notation instead of y1 or y2 minus y1 over x2 minus x1. Okay, this is slope. It's the same thing. Your y values over your x values. Okay? So this would be your function values over your time values. Okay, those are all connected. Got it? Like so, we're going to put it in calculus notation.
Oh, it's calculus.
It's the same thing. This is just a lot more functional for upper level math. What if I were to interpret this graphically? Okay, let's call this time 0. We'll just go by 3 since we're on that unit. This is time in hours. Okay. Then we're going to have position in miles. So we have 3 and 75. Yeah, that's by 75. Oh, just trying to do it easy. And then 6. Now, are we going to be going 60 miles an hour the entire time? No. It's just your average velocity. So your graph of your position versus time might actually look something like this. Like you're going slower and then you speed up, and then you're going like infinitely fast. And then you slow down and get simple. Okay. So this would be your real position versus time. And we have.
Why does it go from 3 to 6 instead of 0 to 3?
Because I'm doing 3 a.m. to 6 a.m. It's the actual time. Yeah. This would be. Oh, I think I can draw lines into this. And I go. What did I just do? Oh, that's the spotlight. That was beautiful. Thanks. Oh, there it is. That's what I'm already on. Okay, you know what? I don't mind. Wait. Trying to draw a straight line. Okay, I want that to be in red, but we'll just roll with it. Okay, this would be average velocity, right? A straight line. The slope of that line is average velocity. How could I figure out the instantaneous velocity? Like if you're traveling along and you're going at infinite speed and this cop goes, bam, I got you with my radar gun and you were going 200 miles an hour.
I don't think that cop's going to be testing you at all.
How could I figure that out on there?
Yeah.
Instantaneous velocity is what this is called.
Instantaneous.
Yes. Okay. Average velocity is a secant line. Okay, it has 2 points. What is the other type of line we learned about?
Any.
Okay. It only has 1 point. So there I try to use that tool here. Did you want to laugh?
Yeah.
What's on the back arrow? The back arrow. At the very left side.
No, right, left, all the way left.
Left.
Okay, get it now. Okay, I think I get it figured out, but I didn't want a wide line like that.
Thinner one.
I can be picky, just don't know how to operate. Okay, so this would be an instantaneous velocity. Okay. Again, we're looking at the slope of that line. And then it's called a tangent. Friday, we went off on a tangent.
No, we didn't. We totally were.
We totally talked about the mathematics of volcanoes and earthquakes,
Yes, we did.
exponentials and logs.
Red rock.
Yes, important.
And why is a Richter scale 9 earthquake a 9 instead of a 10 to the 9? Okay, that's why. So, do you kind of get the idea here of average versus instantaneous velocity?
Yeah.
How do I draw that line on one graph? Just kind of guess.
Yeah. If you want a ruler, I can give you a ruler.
But like, does it have any certain?
No, this is not specific. It would. If you wanted to figure out how fast you were going, you had the function. Like I didn't give you the function. You used calculus to figure that out. That's what we're headed towards. Okay, figuring that out. You can estimate it though. I can estimate the slope of this line. Okay. If I wanted to, I'm getting a little crunched on space here, but what point is that?
Yeah.
575?
Yeah.
And what point is that?
5.5. 1.
Does that look like 6?
No.
That looks more like
5 3/4.
Okay, we'll go 5 3/4 and 200.
Yeah.
Okay, now we can calculate a slope and estimate how fast you're going right there. Okay, right?
yeah.
So 200 minus 75. 5.75 minus 5. Well, you're smoking. It's $1.25 over 0.75.
It's over way too fast to see it. Even that.
Let's see. Divide by 3. You're like in the 165 range. Times 2, but divide by 3. Somebody going to jail.
What do you do?
I didn't do that. Okay, so we have just estimated your instantaneous velocity.
How fast is that?
166 miles per hour.
Somebody's got a car going downhill. Are you good on that? Take that as a yes. Sorry. Do you guys, are any of you in physics? Okay, so this will look kind of familiar. There's a man
What is he doing?
named John C. John C. No, it's not WW. Okay, Galileo came up with this formula for the velocity. Okay, what's the Galileo formula for a falling object? 4.9 t squared. 4.9 t squared.
We'll just go on those.
Okay, a stone was dropped on Mikey's head when he was a young man. I did that, which actually is a curse. So when he was a boy. Alright,
Wait, that literally happened this weekend.
how about that? Okay, so a stone was dropped on Mikey's head. Estimate instantaneous velocity at t equals. What happens when I improvise? 0.8 seconds. Okay, and the formula is S of t equals 4.9 t squared. So it's just what happens? How fast is it going at 0.8 seconds? Estimate it. Because we can figure out the average, right?
Wait, what's the 4.9 again?
This is the, well, gravity, right? Gravity is 9.8 meters per second squared acceleration. When you put it into a formula, 1/2 g t squared plus, okay, it's coming back to you now. There's a formula. This is just part of it. Okay? We're in meters here. So this is the position. At any time, like if I want to figure out the position at 0.8 seconds, okay, that would be S of 0.8, right? So what's that position? That stone has fallen 3.136 meters, like 10 feet.
That was cool.
My waves. Probably.
I'm not dead.
You have how far. Yeah, define stone. Define stone. Define pebble. Define rock.
Yeah, rock should be like.
Define boulder.
My city is.
Okay, so we need to estimate the slope at this spot. Can anybody give me ideas on how to do that?
Well, I'm guessing it's.
So we want, alright, so what's S of 0? Okay, we're chit-chatting today. We need to focus. Okay, can I estimate using these numbers now, a slope? Okay, let's try it. So I'm going to have S of 0.8 minus S of 0 over 0.8 minus 0. That's our formula, right? Function notation. I get 3.136. Somebody do the math. And it's in meters per second. The units there, I can almost guarantee you're going to see that on the AP exam for response. They're going to say calculate rate of change and give us the units. And that's a point. What's the third decimal? No? Okay. So this is good. 3 decimal places. No. So that's just me reiterating that to you guys. Okay, is this very accurate for instantaneous at 8.8 seconds? Go back. I'm used to having smart words. Okay, was this average rate of change a good good estimate for this?
Oh,
No. Okay, so we used a very large interval, right? 0.8. How could we make it more accurate? 0.0. Would that be more accurate? Would be actually more accurate. Okay. What about are we getting more accurate? Okay, can you figure out that without me telling you how to do it? Are you okay with me about that? Okay, so when we're figuring instantaneous velocity, let's actually do this. Who wants to do this one? Raise your hand. Half of you. Okay, this half of the room. Do the top. That half of the room, do the bottom. We want the slope. So you have to figure out the function values and the slope. Ready, set, go. I think that'll be more productive. Yeah. Time zero. Same thing here. Anybody else? Stop.
8.7999. I'm curious on why 2 is 0.
Here?
Yeah.
We chose it to be 0. Somebody said use t as 0. Now I'm just saying we're doing more accurate, so we're choosing t to these sides.
Oh.
Plug it in. Get your position. Average 0.79. But what is the instantaneous velocity? So,
Yeah, I think it's
that's average and instantaneous. They're quite different. So the closer you get using points here and here, the closer you're going to get.
So you get like 3.1.
Exactly. Yeah. That's right. Are we almost there? Okay, 0.79, what's my position? 3.0. Okay. No harm in being more accurate right now. Okay, and? Okay, now, are these the 3 decimal spots? No, because we're still calculating, not until the final answer you go to 3. Okay, what's your slope? You see how much different these are? I mean, that's not a lot in terms of it, but what about this one?
I got 3.135 for the first one. Yeah. And then 3.136 for the second one.
Slope?
I'm not doing it.
Killing your homework out there. You have like 4 assignments for me by the time you leave today. Let's just go over this one. This half of the room?
Yeah, exactly.
I was on that half. I mean, that. Yeah, the best part of me was
Do we need to go back to math 1 and
Yeah.
get fraction circles? Yeah. Half, split it in half.
Yeah.
Of course, the dividing line is like, you have the answer yet? Thank you, Gabby. That's the same. It's really that's weird. Are you sure?
No.
I want the answer. Come on. Somebody check it. Gabby's usually right.
I use both.
You're upside down. Yeah, I know.
Anybody else? You guys are wasting your own time. I'm just standing here until we get another answer. Anybody else? Something's not right here. Are these numbers correct?
Yeah.
Yeah, they look right. And the bracket inside here.
Can it just be that they didn't like the decimal? Yeah.
I actually have to get a calculator out.
No,
I took away the 7 and I got 2.919.
Oh, that's this. Okay, so we have the y's. Minus divided by are you sure? Something's not right here.
Yeah, I got that's what I got. Hey, aren't there? What? Is it because there's one extra decimal on the 8.0001? I got the same thing with that.
Yeah. That's, did anybody get a difference?
I got 9.09.
Well, we actually,
So the point here being, I don't know why this is not working quite right. We do stuff with other kids, maybe I don't worry about it.
Yeah. I think all the
Here's the point. The closer the numbers are, the actual answer is 7.46. So I'm thinking we're doing something wrong, I'm just not seeing it. So the point is, the closer these numbers are, the closer you get to the instantaneous rate of change. Okay. Now, if you wanted to, what is 9.8 times 0.8? Somebody tell me what 9.8 times 0.8 is. That is the instantaneous velocity, because I looked at the function and I used calculus to get that number. See how much faster it is when you know calculus? The point is, the closer these get, the closer they should get to 7.84. Here?
Yeah, that's what we thought. They said it's 0.8. Someone was here reading it out.
Oh.
That's what we thought.
So 7.8. Yeah, I don't know what that problem is. I'll tell you what. Let's try that. I don't think that's the problem. What's 0.7999? Okay. I should change it, but we're gonna give it a shot. Maybe that's the problem.
7.84.
This one?
I got 3.135.
3.125 again. That's not gonna change our answer. Well, we'll change our answer. If we added another decimal spot. I think the moral story here is actually going to be, we're going to need more decimals here. Okay. These are, when you get that accurate, they're pretty picky. So this is what it goes to. As the numbers get closer, you should see them get closer to the actual velocity at that spot, okay?
Are you on track with that? Yeah.
That's it. I mean, there's not a whole lot of material there. It's just putting in calculus context. You get some. All right. Here's your homework. That we do till Friday. So 34 is kind of a challenge problem. Yeah, I've got some spiraling on there, it's due Friday.
Oh, thank you. Friday morning.
What else do you guys have in your possession right now? You also have the, atrocities.
You didn't give that to us.
They weren't here.
No, that gave you the volleyball girl, so you didn't give it to us.
Yeah, that's one.
And the factory house two-sided, right?
Yeah, we didn't get that.
That's due Friday as well.
Oh, my
I was
God.
gonna get it to you today, I think was my other thinking, but, yeah. Did I give you, I haven't had anything else, right?
And then wait, 1, 4,
But I might have just gone.
1, 4, 10.
It's gonna be like a first year.
It's 7. Oh,
I really want to get up. So the quiz tomorrow is about over chapter 1.
Yeah, I wonder why I had so many extras.
Yeah.
That makes sense.
False.
God.